bit of your time to me. Give a little bit, I'll give a little bit of my time to you. There's so much that we need to share, so take some time to show you care. Hey, welcome to this week's installment of video notes from Mr. Flugum's physical science class. This week we're going to be talking about electricity, and because that's the unit we'll be starting on Thursday and Friday. These video notes, you guys, will go on page 45 in your physical science notebook. Thanks for tuning in. Let's get started. So I thought I'd start this time with what you need to know. So here's about 6 things that are really important that I'll cover in these video notes, and we'll also be covering them in in class. You need to be able to identify parts of the atom that move around and cause electricity. You need to tell me how charges interact, how objects become positively and negatively charged. Okay, we're going to talk about static electricity, and then we're also going to talk about electrical current. And then last but not least, we'll end up these video notes talking about 3 factors that affect electrical current and something called Ohm's law, which is a really important law when it comes to electricity. Well, let's get rolling. Alright, so let's just start with a quick review here of atoms and their structure. Alright, remember protons, those are the positively charged particles. They're stuck in the nucleus in the middle, and they can't move anywhere without the whole atom moving. Alright, then you have electrons, and they basically buzz around the outside of the atom. Right? They have a negative charge, and they can leave. They're a lot more free to move. And if you remember back to our study of ions and things like that last fall, what charge is an object when it gains electrons? So remember, when it gains electrons, that means that it is gaining negative charges. So if it gains electrons, it becomes negative. What charge is an object that loses electrons? Well, if it loses electrons, what's left over? Protons. Those are positively charged. So an object that loses electrons becomes positively charged. I think a lot of you are familiar with this too, electrical charges, right? Remember, opposite charges attract, right? Like charges repel. So negatives don't like to hang around right next to negatives, and same with positives. Alright, so let's start with static electricity, right? So static, if you remember, means not moving or stuck in place, kind of. Alright, so static electricity is extra charges that are stuck on an object in one place. Alright, you can either have positive or negative static electricity, right? You think, well, why does something have positive static charge? Well, that's because it lost electrons, right? So if you look at that cat there, that cat is kind of falling victim to a static charge right now. Its fur is maybe negatively charged, and it attracts all those styrofoam balls, which maybe have a positive charge, the opposite charge from its fur. While it doesn't look very happy, that's what's happening to it. Alright, well, what causes static electricity? Before you answer, let me just let you know it's not friction. Sometimes students think that because they see things like rubbing your feet on the carpet or rubbing a balloon against your hair causes static electricity. But that's not always that. It has to do more with the materials involved. Some materials really like electrons, and electrons go to them. Other materials give them up. For example, a balloon that you might rub on your hair attracts electrons to it. All right, electrons stick to it very easily. So because it gains electrons, it becomes negatively charged, right? Your hair, since it gives up electrons, becomes positively charged. Okay? That's what makes your hair stick to the balloon, right? It's because they have opposite charges. And as we know, opposite charges attract. Now what eventually happens is this. You have static discharge, right? So when you get all those charges that are alike next to each other, all right, they don't like to be there. Okay? They repel each other, remember? So eventually they need to go somewhere. And when that happens, it releases energy. All right. Now, that means this static charge can jump across distances, right? In fact, it can jump thousands of feet, such as with lightning, right? When it discharges into the ground. It can jump across the air from your finger to a doorknob, right? You don't even have to touch something to have a static discharge happen. When that happens, there's lots of energy released, and that excites the air into plasma state. All right, well, moving on from static electricity, let's talk about electrical current. All right, so current is different. This is a flow of charges, right? And we can kind of think of electricity as kind of like water flowing, except instead of water, it's electrons that move. All right, so there's two kinds of circuits when we have current, right? So you have a closed circuit, all right? A closed circuit means you have a loop, a continuous circuit or circle that allows charges to flow through them, all right? Now this has to be a conductor, right? Like a metal that electricity can flow through, all right? On the other hand, you might have an open circuit, which is an interrupted loop. So that might be a circuit where the light switch is switched off, right? And there, the charges can't flow. So in order to have current, you have to have a closed circuit. When we measure current, there's three things that are big time influences on it. You have amperes, voltage difference, and resistance. You can see the three things there, right? So amps is how many electrons are flowing through the wire, right? Voltage difference is how much push is there on those electrons. And resistance is obviously how much resistance there is to those electrons flowing. When it comes down to it, we get Ohm's law, right? All three of those things are related to each other. And Ohm's law basically says this, right? Current equals voltage difference divided by resistance, right? Or amps equals volts divided by ohms, okay? And this helps us understand a lot about how electricity works, how much current is flowing through a wire, how much push there is, and how different materials' resistance affects that flow. All right. Well, thanks for tuning in. We'll be covering all of this stuff in class over the next week or so. And I will see you in class on Thursday or Friday. Be ready for your quiz. Thanks a lot.